Greetings was asked to cover a couple of problems from section 3.1. First one was problem 7, the worked example on function division, to remind you a little bit about how that goes. There's actually also a problem in the problem set that reminds you of this, and we'll be doing that in a separate video. So first of all, what you need to recall when doing function division is that you are basically taking in the numerator a function and dividing it by a function in the denominator. And then on top of that, you got to remember a few of our little rules from exponents from your previous coursework. The base one is that if you have a raised to the m power in the numerator and a raised to the n power in the denominator, then that can be simplified by rewriting that as a to the m minus n. So let's go down and take a look at this first example, part A of problem 7. So f of x is equal to 15x to the 15th divided by 3x to the 9th. So let's take this a couple extra steps here. So one way of thinking about this is 15 over 3 times x to the 15th over x to the 9th. Notice if I multiply together the numerators, multiply together the denominators, I'd end up back with the previous expression. Okay, let me thin up my pencil here just a bit. So notice that the 15 divided by 3, that's going to simplify to 5. And the x to the 15th divided by x to the 9, well, that's x to the 15 minus 9, as we see over here in the worked part of the example, which gives me 5x to the 6. Okay, so one of the things that's interesting about this very cool property here, in other words, the property that says a to the n over a to the m is equal to a to the n minus m, is that sometimes that leads to negative exponents. So for example, if we'd given you x to the 5th divided by x to the 9th, then that would be x to the 5 minus 9, which ends up giving us x to the negative 4. Well, by definition, a negative exponent means you're to reciprocate. In other words, that means this is going to be 1 over x to the 4th. And that definition shows up down here. Again, that's a review from elementary algebra that you're supposed to have brought along with you, okay? So in part B of this worked example, they take advantage of that property and they say, well, look, again, if I divide f of x by g of x, that's going to be negative 4x to the 5th divided by 2x to the 8th. So let's take that extra step we did in the upper one and let's break up that fraction. So that's negative 4 over 2 times x to the 5th divided by x to the 8th, which gets us back a negative 2 on the coefficient, then x to the 5 minus 8. Well, 5 minus 8 gives us back a negative 3, so that's negative 2x to the negative 3rd, and then by definition, that'll be negative 2 times 1 over x to the 3rd. Well, recall how to multiply together fractions. We multiply numerators, multiply denominators, and that just simplifies to negative 2 over x to the 3rd. Okay, hopefully that helps. Let's scroll on down to problem number 12. That's your turn, number 12 here, or you try. It says, use the graph to determine each of the following. Assume integer answers. The graph of G is the graph in bold. Okay, so first thing we have to do is go down here and fill out this table for f and g. So let's go ahead and do that. Now, they did the first one for us on f. So this is the set of ordered pairs that make up part of the function f and part of the function g. So hopefully first thing we can see is, let's go ahead and do a little bit of color here, is that we see that this stretch of the function f all is going to get mapped to 2. So from negative 7 all the way up to negative 3, every one of those is going to get mapped to a 2, because it's a horizontal line, isn't it, right? And then when we get to negative 2, it looks like we're going to be at 1. At negative 1, it looks like we're going to be at 0. At 0, it looks like we're at 1. At 1, it looks like we're back up to 2. At 2, it looks like we're back up to 3. They say assume integer values all the way along here to make our life easy. And then at 3, it looks like we're up to 4. And then once we hit 4, let's see, 1, 2, 3, yep. And then when we get up to 4, it looks like we are now, let's see, it says assume integer values here. Let's go ahead and use the line tool to help us out here. Okay, well, they say we get to use integer values here, so we're going to say they were dorks and that they meant to make that a 5. Okay, we'll just assume that just to make our life easier, because they did say we could use integer values. So for all the rest of these, this is going to get paired with 5. Badly drawn. Bad job, guys. Okay. All right, so let's go ahead and take a look at G. Let's go ahead and change the color on G so that we can help differentiate them here. We'll go to blue on that. So in G, they tell us at -7, so 5, 6, 7, we are at 3. So that point right there is at 3. So at -6, which would be right here, looks like we dropped down to 2, right? At -5, it looks like we drop down to 1, I would say. Yeah, it looks like we drop down to 1. And then at -4, we're at 0. At -3, looks like we're at -1. At -2, it looks like we're at -2. At -1, looks like we're at -3. At 0, looks like we're at -4. And now we're going to come back up the other way. So at -1 would be the same as +1, so we're going to be back up to -3, then -2, then -1, and then 0, and then 1, 2, and 3. Okay? All right, well, aside from the faux pas that they definitely messed up here, we got our sets of ordered pairs. Okay, so now we can use this to go answer some questions. So they ask us to fill in the following table here. So let's go change color one more time just to keep these straight. Okay, let's go for dark purple, let's say. So G of 4. So we come over and look on our list. Where is G of 4? Here is G of 4 right here. So G of 4 is equal to 0. On B, we want to find F of 2. Let's see, there's F of 2 right there. That's going to be a 3. Let's see, what's G of 0? G of 0 looks like it's a -4. If f of x is equal to 0, x equals, okay, so this time they're saying go look for, oops, sorry, skip D here. What's f of -6? Let's go do that first. That's a 2. So if f of x is equal to 0, x equals. So let's see, now we're looking in for the y value being equal to 0. So that's an f of x equals to 0 right there. So the x value must have been equal to -1 there. If g of x is equal to 0, let's see, where was g of x equal to 0? Ah, that's right there. That's where our g of x is equal to 0. So g of x is equal to 0, x must have been equal to -4. If f of x is equal to 1, if f of x is equal to 1, let's see, f of x is equal to 1 at 2 places. It's equal to 1 there, and it's equal to 1 there. Because there are 2 places where f of x is equal to 1. And if we come back up to the graph, that makes total sense, see? It's those 2 spots right there and right there, okay? Excuse me, my sloppy drawing there. But going by our table, that's going to be at what? X is equal to -2 or x is equal to 0. Those are the 2 possible values. If g of x is equal to -4, let's see, where is g of x equal to -4 at? Well, there's one place where g of x is equal to -4. Is there any other place where g of x is equal to -4? Let's see. Give me a sec here. Nope, there's only one spot. Looking at the graph again. So that's at x equals to 0 because that was the smallest part on that graph, right? Okay, so what's f of -1 plus g of -1? So we need to go back up to our table here and figure out where f of -1 is. F of -1 is 0. G of -1 is -3. So that gets us back a -3. G of -6 minus f of -6. Let's see, g of -6 is a 2. That's right here. And then we're going to subtract from that f of -6. Let's see, f of -6 is a positive 2. So that's going to come out to be equal to 0. F of 1 times g of -2. Let's see, f of 1 is 2. And then we'll use the asterisk here to indicate multiplication. And then g of negative 2 is a negative 2. So that's going to come back out to be a negative 4. And they want to know g of 6 divided by f of negative 1. So let's see, f of negative 1 is a 0, and g of 6 is a 2, and this does not exist. This is a DNE because you don't get to divide by 0. Okay, now realize that was fairly fast, but you can rewind it, watch it again, stop and pause and look at the pieces you need additional help with. If it doesn't help, please let me know. Go ahead and post another question in the Q&A form, and I'll do whatever I can to help.